So hello everyone, welcome back to the channel. Hope you are all fine. So our today's question is largest rectangle in the histogram. So this question is very famous. To calculate the maximum area rectangle or maximum area rectangle that can be made using the bar charts. So the problem statement says that we have given a bar chart and there are multiple bar graphs and every bar chart have their x height and we have to return the maximum rectangle area that can be possible. So this is our task and we will take an example. Suppose we have given a chart of 2 1 5 6 2 3. These are the elements and for the mm, for the bit width we have only a one distance, means 1 centimeter distance is given as their particular width, and for the height we have given as five different elements index heights. So this is the problem statement. So what will be the maximum area that can be possible, and we can make the maximum area length rectangle. So in this question we have to basically calculate their next greater element and previous smaller element, or next smaller element and previous smaller element, so that we can calculate the maximum height possible area rectangle. So let's analyze for the two, like the next smaller element is 1, and before this we can travel in that direction only, and after that we cannot travel because next element is just smaller than our previous element, so maximum height will not be possible at that rate. So for 2, our area will be as 2 cross 1, means 2 in its height and 1 will be in its width, and with this it gives the answer of 2. For the one, our maximum length will be, it can go up to the last node or the last chart, and with this its area will be 1 cross 6, means 1 will be its height and 6 will be the maximum length that we can reach up from that element, and we can traverse in left as well as its right direction also. So that's how its maximum area is 1 cross 6, that means 6, and for 5 it will be as 5 cross 2, means we have to calculate the next element, either it is greater or it is smaller. If it is greater, so we can traverse in that direction, and whenever the smaller will be encountered, so we cannot traverse in that direction after that or on that element. So that will be the maximum length that we can traverse in right direction. Similarly we will check for the left direction also, and with that we will get our total length, total width of our element, and the height is given as our current element's height, and we will be multiplying both and getting the our maximum area. So we will take a max for the brute force. Now just check the brute force. For this we will, so I have already told the strategy. We will move it in our left direction as well as in our right direction. We will move until our next element is smaller or our previous element is smaller, and whenever that encounters, we will reach back and return our NAC minus PSE, means next smaller element index minus previous smaller element index minus 1. That will be our maximum height that can be possible, as we can calculate the width of that rectangle by using NAC minus PAC minus 1, and our current element's height will be used as its height, and after multiplying this, means array of I multiplied by NSC minus PSC minus 1 will be our formula, and we will able to calculate our maximum element's height. Whichever will be the maximum will replace our maxi. and that will be that our brute force. For brute force, firstly we have to calculate the previous smaller element, and next we have to calculate the next smaller element. And when we um, found both, we will multiply and put them in a formula, that is array of I multiply by NSE minus PSE minus 1. With this, we are able to calculate the area for the current array element, and just comparing whichever will be the larger area, we will just return that area. So this is the brute force. For time complexity, its time complexity will be big O of 5n is big O of n and 2n for NSE, big O of 2n for PSE, and big O of n for the traversal. So overall its complexity is big O of 5n, and space complexity will be big O of 4n, as we will be using stacks to store element for NSE, PSE, and for this question also. So this is not the best approach because it is checking maximum area, and our we have to target to fix it with a big O of n area and big O of n time complexity. For that, the optimal solution will be found by the formula itself. So our formula have to found two major values, that is NSE and PSE, means next smaller element and previous smaller element. If we are able to found both without writing their code or without writing their extra space and taking extra stack and putting them, so either it is possible or not. So yes, it is possible. It is possible if while traversing from left to right, we will able to calculate the previous smaller element very easily and comparing its value with our next element. If it is smaller, then we just put in PSE, and if it is not, so just change its value. So that's how we will able to calculate the PSE. But our major task is to calculate the next smaller element, because if we are at point x and our NSE will be after x, so we are not traversing or we have not traversed yet, and we have to come back and forth to calculate the overall NSE. So we have to take NSE and put it in a stack. It is the solution, but we does not want to do that. So what will we do? For this, I am taking an example of 3, 2, 10, 11, 5, 10, 6, 3. These are different height of our every element, and with a width of 1 centimeter of their every element's width will be this, and height I have told earlier. So we will be putting all in our stack and traversing and check what will be happen. So firstly, at a 0 index, we will put 3 inside our so we will be putting the index in our stack and comparing the values. So for first, we will put 0 index and put 3 in our value, and after this our next smaller element is 2, means our next smaller element we have get it the next smaller element. So for this we will be pop, because now our next smaller is 2, so we have to pop out 3, or we have to pop out the 0 index first. So while popping out, we will be calculating their area or the possible area for them. So for the 3, we have know that now we have know that NSE will be 2, while PSE, because there is no such element, so that will be -1. So we will be putting that NSE as 2 and PSE as -1 and putting it in our formula, and it will be able to find out their area. Now for the 2. So for the 2, our strategy will be as we have to check for every element at least once. So that will be our strategy. So for 2, our PSE will be as no element have encountered yet, so will be as -1. While NSE we will check further, so we will push one in our one index 1 in our stack and value as 2. And now again moving forward, we will check for 10. For 10, PAC will be as 2 because it is smaller, while we will check now moving forward, because there NAC is not evil because next element is 11. So for 11 our PAC previous smaller element will be as 10 because it's just smaller than 11 and it's the PAC. While NAC, for NAC we will move forward and check whether there is NAC or not. So for the 11, 5 is now our NAC. So 5 is the next NAC for 11. So we have got the NAC for 11, and after this we have no we will be calculating the maximum area for 11 itself. So for the 11 our area will be 11 cross 1, that is 11, while for now we will just pop out our 11 and their index 3, and after this we will checking for the 10. Is 10 is our for the 10, 5 is the NSE. So maximum area that it can provide will be 10 into 2, that is 20. And with this our pointer will move forward from 5 and pushing the 5 in our stack with its index, and again the 10 encounters as next element row, and we will be calculating that also. So let's come up on the pseudocode. That's how we will be able to solve this problem. So discussing the pseudocode. So for this we will be taking a stack st, while maximum area will be compared as 0, and we will be running from 0 to n minus 1 loop and traverse for each and every node. And now we will check our stack empty, and while our stack is empty, our array's stack dot top element should be greater than array of 5. If it is the case, so we have to pop out element, and before popping out we will just store that element as our stack dot top element. And now our NSE will be stored, NSE will be the current index, that is I. NSE is equals to I. Next smaller element will be the I element, and PSE will be stacked. If for PSE we will also check that as our stack is empty. If it is empty, then we will put -1, else our stack's top element will be our previous smaller element. So that will be our PSE. So before calculating PSE we are just calculating NSE while using the while loop. So we have got our NSE and PSE. Now we will be putting them in our formula and comparing whichever will be the maximum value. Means maxi comma our array element, because element is the index, and we have for the height we have to take that array's element. So array of element multiply by NSE minus PSE minus 1, and whichever will be the greater will be our maximum. And after this we will be just pushing back st dot pushback of I. So we are pushing the index in our stack. And now for the next condition, there are some cases where we does not get any NSE and we does not get any PSE. So for the PSE we have discussed, while for NSE means next smaller element. Suppose there will be a case that we does not get any further next smaller element. So for that, what will be the maximum area? So for that we will be taking a hypothetical index after our last index, and that index minus current PAC minus 1 will be the maximum length, and maximum width and length will be given in our bar graph, and after this we can calculate that area. So for that our loop will be checking is our stack is empty. If it is empty, so we will be checking loop. While it is not empty, our NSE will be get up to n, while our element will be as our stack dot top element, and we will be just popping out that element, and PSE will be calculated if it does not have any element in our stack, just return -1, as our stack dot top element will be as our PSE. And after that we will be putting them all in our formula, and at the end we will be returning the maximum area. So that's how we will able to solve this problem, and with this our time complexity will be reached to big O of 2n, and space complexity will be big O of n. So this is the way by which we can calculate maximum area a histogram, and with this we will be we will be maintaining our stack and queue problem playlist continuously, and we will soon make another problem and meet with you. Until that, stay tuned, stay happy. For tomorrow we will get a quick revision of stack because it is necessary, and this question I have understood the question but does not understand well much. So we will be repeating this question again tomorrow with some more visualization of this concept, and until that, stay tuned, stay happy.